and I'm going to be doing problem number 16. So here we're given the determinant, which is on top, a, b, c, d, f, g, h, I is equal to 3. So we know that the determinant of this matrix is equal to 3, and we're asked to solve for the determinant of a, b, c, and then we have the negative 2d, negative 2e, and negative 2f, and then we have a plus g, and b plus h, and c plus I. So the first step I wanted to do was try to get this matrix to look like the one that we're given. So what I went ahead and did and saw was that on the bottom part we have the a plus g, b plus h, and c plus 1. And what we're able to do is we're able to separate that to two different matrices. So what I went ahead and did was separated those two into two different matrices. Here we have a, B, C in one matrix, and then we have G, H, I in our different matrix, and we can see the difference here. And then once I did that, I then went ahead and tried to see what else was different from the given matrix, and we can see here that we have a negative 2 given to each of the row 2s. So my next step was to take out the negative 2 and see if that gets us the given equation, the given matrix. And when I did that, we went ahead and get this. So I take out the negative 2, and then we have D, E, F, and then when I remove it from the other matrix, I get D, E, F as well. And then here we see that this on the matrix on the right looks exactly like the one we're given. So we can leave that as 3. And then the first matrix that we're given, we see that we have an ABC, and then we have an ABC on the bottom, so we know that row 1 repeats twice. And because row 1 repeats twice, we know from the properties that if any two rows or columns are the same, then the value of the determinant is 0. So because these two rows are the same, row 1 and row 3 are the same, we know that this determinant of this matrix is equal to 0. So when we go ahead and write it out, simplify it, we get negative 2 times 0 plus negative 2 times 3, since this matrix on the right over here is equal to the one that we're given, which is here on the top. So we're able to make that a 3, and once we solve that, we get a negative 6 plus 0, and then our determinant for this equation is negative 6. Okay, so that's for part A. And then for part B, here we're given matrix F, A, B, C, D, E, and I, G, H. And to solve that matrix, I went ahead, or not solve the matrix, to find the determinant of the matrix, I went ahead and did the method of solving the determinant. So here I have the plus, minus, plus on top, and then I went ahead and made it into, when we're solving a determinant, I have here F, and when we have an F here, to find the subspace, we then go ahead and multiply this part of the matrix to F. So you can see here that I put it into here. And then we do the same thing for A. So for A, when you're going to solve the subspace, you just ignore this row and ignore this row, and we just take the C, I, and the EH and put into its own subspace, so which is here. And then we make sure we put the negative in front of the A. And then when we're solving for B, we go ahead and do the same thing. We ignore the top row and ignore the column of B, and then we just multiply it to whatever is left. So we have C, D, I, G. And once we have that, we then go ahead and multiply our matrices, our subspaces from the matrix. And then here we have our determinant, which is F. And then when we're multiplying this, we multiply crossways. So we multiply D times H, and we get D times H, and then we multiply E times G, and then we make sure to subtract it to each other. And then we do that for A and B as well. So you can see here I did CH, so I have CH here, and then EI, and then subtracted by EI. And I do the same thing for the B, CG, and DI. And this is where I left off. You can't really solve beyond this. The matrix that we're given is a bit complicated, since we can see from the beginning that column 1 is swapped with column 3 from the original. And if we were to swap it back, we would then get A times B of F and D, E, C, and G, H, I. And beyond that, there's not really much we can do to get it the same since the F and the C are swapped with each other. Beyond that, I don't think we're able to get it to the given equation. So I just went ahead and left it as this determinant here. And yeah, that's what I did for number 16.